Assignment problem is a special form of linear programming model that involves determining the most efficient assignment, such as people to certain projects and any other possible assignments. The main objective of this type of problem is to minimize. There are three main steps of an assignment problem. First, you need to do the row reduction, and then column reduction, and lastly, optimality test. In any job shop operation, 4 jobs may be performed on any of 4 machines. The hours required for each job on each machine are presented in the following table. The plant supervisor would like to assign jobs so that total time is minimized. Find the best solution on which assignments should be made. For the step 1, we have the row reduction. In this step, you need to subtract each number in the row by the smallest value in that row. So in this row, we have 10. And in this row, we have 12. In this row, we have 9. And in this row, we have 14. So you need to subtract these numbers to 10 and so on. So we have now the new table. For this step, we have the column reduction. In this step, you have to subtract each number in the column by the smallest value in that column. So for this column, we have 0. This one, we have 1. We have 3. And 0. So we now have this new table ready for the optimality test. The first one, we need to have the cover all zeros with the least number of lines possible. So for this row, we have 0. For this row, cannot be. For this row, we have this one. And for this column, we have this one. The next thing you need to consider is the last number of lines should equal to the number of unique assignments. So what we have here is 3 lines with the 4 assignments. So still it is not optimized. Since this one is not yet optimized, we need to find the minimum value that is not crossed out from all other values not crossed out. Then add this value to those cells where 2 lines intersect. So we have here 1, which is not crossed out. So what we're gonna do here is we're going to add the 1 to those lines that are intersecting and minus to those that are not crossed out. So we now have here the new form. This one, it goes in the same process. So we have here for this row, for this row, not yet. For this row, for this column, for this column, so we already have 4 lines and 4 assignments. This means that A12 job should be assigned to W machine, and A15 job should be assigned to Z machine, and for B2 job should be assigned to Y machine, and for B9 we have X machine.
Transportation model. Transportation problems deals with the distribution of goods from several points of supply or sources to a number of points of destinations or demand. There are 3 different ways to solve for the initial tableau that will be discussed in this tutorial. First, you are to set up a balanced transportation table. First, let's discuss northwest corner rule. Assign largest possible allocation to the cell in the upper left-hand corner of the tableau. Repeat until all allocations have been assigned and an initial tableau is obtained. This is the initial tableau for northwest corner rule. Next is minimum cell cost method. Find the cell that has the least cost. The least cost is 2. Then choose which cell to start. Assign as much as allocation to this cell. That would be 30. Then subtract the allocation from the capacity and supply of the respective cell. Block those cells that cannot be allocated. Repeat steps until all allocations have been assigned. This is the initial tableau obtained using the minimum cell cost method. Lastly, we have Vogel's approximation method. For each column and row, determine its penalty cost by subtracting their 2 of their least cost. Then, select row or column that has the highest penalty cost. Here, that would be 1. Then, this is the column that has been chosen. Assign as much as allocation to the selected row or column that has the least cost. The least cost is 2. Then, 25 is allocated. Subtract the allocation from the capacity and supply of the respective cell. Then, block those cells that cannot be furtherly allocated. Repeat steps until all allocations have been assigned. This is the initial tableau obtained. Then, solve for the total cost. That would be the summation of the product of the cost and its allocation. For this problem, the minimum cost will be $230 using the minimum cell cost method.
The next topic is network models. We will discuss 2 of its type, the shortest route and minimal spanning technique. In shortest route technique, we are to determine the shortest distance from node 1 to each of the rest of the nodes. So we have this example. What we need to do first is to find the nearest node to the origin. In this example, we set node 1 as our origin. Put the chosen distance by the node. So, next, find the next nearest node to the origin and put the distance by the node. In some cases, several paths will have to be checked to find the nearest node. So in here, we have another path. Then, repeat the process until you have gone through the entire network. So next is we connect 3 to 4. Then connect 4 to 5. Connect 3 to 6. And finally, connect 4 to 7. The last distance at the ending node will be the distance of the shortest route. You should note that the distance placed by each node is the shortest route to this node. These distances are used as intermediate results in finding the next nearest node. This is the summary of your shortest distance from node 1 to each of the rest of the nodes. Now, in minimal spanning tree, we are to determine the shortest distance to connect all nodes in the network. Using the same example, first, we select any node in the network. Here, we can choose the shortest distance among all distances of the entire model. So we choose 8 and we connect the node 5 and node 7. Next is to connect this node to the nearest node that minimizes the total distance. Considering all of the nodes that are now connected, find and connect the nearest node that is not connected. If there is a tie for the nearest node, select one arbitrarily. A tie suggests that there may be more than one optimal solution. So in this case, we can connect node 5 and 4 and node 7 and node 6. Now we will just repeat the previous steps until all nodes are connected. So we connect node 2 to 4, then can connect node 3 to 4, and we can also connect node 1 to 3. Now all nodes are connected, therefore you have arrived to the optimal solution. Summing all distances will give you 72 units as the shortest distance that connects all nodes in the network.